Good day to all of you. Today we shall discuss about prime implicants and essential prime implicants. This is related with K-map technique. In that three variables Boolean equations we are going to consider. So simplification of three variables Boolean function using K-map that I have covered in last video. So this will be the extended version of that one. So the keywords to be remembered: minterms, sum of products. These are from last video. For that you can refer to my last video on K-map with three variables. Next, in today's discussion, another two key terms will be introduced. What are prime implicants and essential prime implicants? So we shall consider example 1. How to simplify the given function f1, which is sigma m of 1, 4, 5, 6, 7. Here in the function 7 is the biggest one. This is minterm x, y, z, means it needs minimum 3 variables. Hence given function is 3 variable Boolean function. Sigma m indicates it is sum of minterms 1, 4, 5, 6, 7. Each are product terms here. So the given Boolean equation is in the form of sum of products form. 1 means x dash y dash z. 4 means x y dash z dash. 5 means x y dash z. 6 means x y z dash. 7 means x y z. If x, y, z are taken as input variables. So the problem is to simplify given Boolean function of three variables using K-map. Hence the solution is as follows. 3 variables means 2 raised to 3, 8 squares K-map we have to draw. Right? This is 8 squares K-map. 1, 2, 3, 4, 5, 6, 7, 8. So x, y, z. 3 variables we write here. The taken variables for this are x, y, z. We can take as a, b, c also. So this is K-map for f1 function. So K-map for f1. So x can have 0 value or 1 value. Y, z, these two variables can have combination 0, 0, 0, 1, 1, 1, 1, 0. Then in the Boolean expression 1 is present. This is minterm 1. This is m naught place. It is not there in the given Boolean function. 0 is not there. 1 is there. So this is m1 place. We'll put 1 there. 2 is not there. 3 is not there. So this is 2's place. This is m3 place. This is m2 place. m3 place. We will put 0. Then 4. Minterm 4 is present, hence 1 in m4 place. This 5, m5 place. This is 6, m6 place, and 7, m7 place. So whichever minterms are present in the given Boolean equation, in their place in the K-map we will fill ones. In other places, minterm 0, minterm 2, minterm 3, they are not there, hence they are written 0 here. So the first step, drawing K-map and filling the values, is over. Minterms we have filled here. Next we'll have to group this, right? So how to group this? So now here 1, 2, 3, 4, they are adjacent ones. It's a rectangular group we can draw. Diagonal group we cannot draw. So rectangular shaped group having adjacent ones. So this is group 1. So 4 ones are covered. To cover this one more group, so octet, all 8 are not ones. Then we have drawn here quad, group having 4. So with this can we draw octet? No. Can we draw quad? This quad we cannot make because 0 is here. Then we'll have to try for pair. So this will form a group of pair. So this we will call as second group. Hence the solution is f1 equal to, with respect to group 1, 1, 2, 3, 4 ones are there. All fall in same row with x is equal to 1. So row wise x is common. Then 1, 2, 3, 4. This column, this column, this column, this column. So column wise 0, 0 here, 0, 1. So this 0 is common. But all 4 means they are covered in all 4 columns. So nothing is common. So column wise we shall leave. So first group row wise column wise writing is over, and this one we call it as prime implicant. So row wise column wise what group we are going to write as AND operation of the literals, that is called as prime implicant. Then with respect to this group, so there these two ones fall in these two rows. Here x is 0, x is 1, nothing is common. Column wise these two ones fall in this column. So 0, 1 is common for both ones here. This 0 corresponds to y, hence y dash. This 1 corresponds to z, hence z. Y dash z is common. So the solution is this one. So f1 simplified function, that is equal to x plus y dash z. This is example 1. Okay. Next we shall consider example 2, where f2 is sigma m of this 0, 4, 5, 6, 7. Okay. Now solution. So we will draw K map of 8 squares. It is a 3 variable Boolean expression because the biggest minterm is 7. 7 to express 3 bits are needed. Let us take the 3 inputs as x, y, z. We will write here x, y, z, 0, 0, 0, 1, 1, 1, 1, 0. X can be 0 or 1 here. So minterm 0, m0 is present. M1 is not present. M2 is not present. M3 is not present. M4 is present, 5 is present, then M6 is present, M7 is present. So how to draw the K map and where the minterms place to come, this I have covered in my previous video, K map with 3 variables, that you can refer. So now the grouping is, these are adjacent, so it makes a quad. Octet is not possible, all 8 are not ones. Then we have to go for the quad. Next 4 ones are covered with this quad. This one is not covered. So to cover this we will make one more pair here. This is second group. This is first group and this is second group. Hence F2 is equal to, with respect to first group, all are in this row, x is common, and 1, 2, 3, 4, they fall in 4 columns. With column wise nothing is common, so we will leave that. Then we shall go to group 2. These two ones are there in group 2. So for these two ones, they are covered in these two rows. X is 0 here, x is 1, nothing is common. But both ones fall in only one column. So 0, 0. This 0 corresponds to y, hence y dash. This 0 corresponds to z, hence z dash. So y dash, z dash. So this is the simplified solution for example 2. Okay. Next we shall consider example 3, that is f3 equal to sigma m of 0, 2, 4, 5, 6, 7. How to simplify this using K map? So for that we shall draw K map of 8 squares because it is also of 3 variables. So this Boolean equation is also of 3 variables, 2 raised to 3, 8 squares are drawn. Let x, y, z be the 3 variables. X is written here, y, z is written here. For these two variables y, z, 0, 0, 0, 1, 1, 0, 1, 1 are the possible 4 combinations. X can be 0 or 1. Now after drawing K map, we'll have to fill these minterms. So M0 is present, 1 is not present, this 2 is present, 3 is not present, 4, 5, 6, 7, minterm 4, 5, 6, 7, they are also present. So after filling K map, we have to group the ones. Octet is not possible because all 8 are not ones. Then we'll have to try for quad. So this quad we can make, let this be first group. Then how to cover this? Now octet, is it possible with this? No. Next, we should not suddenly jump into pair with this. Think whether quad is possible. Now this and this are adjacent. This and this also will be adjacent. This and this are also adjacent. Hence these 1, 2, 3, 4 are all adjacent. Hence they make a quad. Otherwise here on this line, if you take a fold, these two fall on this. Again on this line, if you take a fold, all fall on one square. Hence, I repeat, on this line, if you fold this, these two one fall on this. Next on this line, if you fold again, all fall on one square. Hence 1, 2, 3, 4, all they make only one group, that is quad group. So that is grouped as second quad. So this is a second group. It is a quad having 4 members, 1, 2, 3, 4. With respect to first group, so all 4 ones in one row. So x is 1 means x is common here. Then column wise is all 4 ones come in 4 columns, nothing is common here. So leave that. Or then go to second group. These two ones form second group, that is a quad. Now these 4 ones, they are covered in this row and in this row. So x is 0, x is 1, nothing is common. So leave that. Then column wise, these two in this column, these two in this column. All the 4 if you take, in 2 columns they are covered. So this column and this column. Here we have 0, 0. Here we have 1, 0. So what is common here? 0, 0. This second 0 corresponds to z. Hence z dash. So with respect to second column, z dash is common. Hence the result is the simplified f3 is equal to x plus z dash. Okay. Next we shall consider example 4. So simplify f4 is equal to sigma m of 1, 3, 4, 6. Right. The solution here, it is of 3 variables because biggest midterm is 6. To express this 6, minimum 3 bits are required. Hence it is a Boolean function of 3 variables. So we draw 2 raised to 3 8 squares. X, Y. X, Y, Z are written here 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So K map of 8 squares is drawn. One variable x is written here. 2 variables yz are written here. Yz combinations are 0, 0, 0, 1, 1, 1, 1, 0. X combination is 0 or 1 it is. Now we'll have to fill this minterm. M1 is present means 1 here. 2 is not present, 0. 0 is also not present. 3 is present. 4 is present. 5 is not present. 6 is present. 7 is not present. K map is filled. Now we'll have to group ones. Octet is not possible because all 8 are not ones. Now quad is also not possible anywhere. Okay. Next we'll have to go for pair. So these are adjacent, hence it is a group 1. Let us call this as group 1. Now if you take a fold here on this line, if you fold this, this falls on this. Hence this and this make a pair. Right? So this is second group. Hence the simplified solution F4 is, how many terms we'll have to write? 2 terms because 2 groups are made. With respect to first group, there are 2 ones. Both fall in this row where x is 0, that is x dash is common. Then for these both column wise, see this one in this column, this one in this column, 2 ones of this group are covered in 2 columns. Hence here 0, 1, here 1, 1. This 1 is common, that corresponds to Z. So we write and Z. We call this as X dash and Z or X dash Z. So this is prime implicant. This also is prime implicant. This also is prime implicant. After grouping what row wise, column wise are common, we write they are called as prime implicants, right? So with respect to first group, one prime implicant we have written. With respect to second group, so these two ones covered in this row, so X as one, X is common. So here first group is over, then OR. With respect to second group, these two ones, X is common. And column wise, this column and this column, because members of second group, two ones are there. So to cover both, for covering both this column, for covering this one, this column. Here 0, 0, 1, 0. This 0, 0 is common with respect to Z. Hence we'll have to take Z dash. So this is the simplified solution. What is the solution? F4 is equal to X dash Z plus XZ dash. So plus means here logical OR. How to read? F4 is equal to X dash Z or XZ dash. These two are called as prime implicants. Are they essential prime implicants? How to know this? Because there are two groups, only they can be made, no other group. And what prime implicant we have found for each group, they are included in the simplified solution, final solution for the given Boolean function. Hence both are essential prime implicant. Because this prime implicant, if you take X dash Z with respect to group 1, so this one is covered only in this group. Here for with respect to second group, this one is covered only in this group. And the resulting prime implicants will be essential prime implicants. So in any group, if there is at least one which is covered only in that group, then prime implicant with respect to that group is called as essential prime implicant. Here two groups are there, two prime implicants we can write, and in each group one is there which is covered in only that group. Hence both are essential prime implicants. So this we can understand when we go for next example in more better manner. Okay. So let us consider fifth example, Fi equal to sigma m of 1, 3, 4, 5. We'll have to simplify this using K-map. Then solution is 3 variables means 8 squared K-map we'll have to draw, because bigger number of minterm is 5. To represent 5, 1, 0, 1, it is in binary. Minimum 3 bits are required. Hence the given Boolean equation is of 3 variables. Hence 2 raised to 3, 8 squared K-map we will draw. Let x, y, z be the input variables. X we write here, y, z we write here. So different combinations of y, z, 0, 0, 0, 1, 1, 0 here, 1, 1, and x can be 0 or 1. So after drawing K-map, we'll have to fill minterms. M0 is not present, M1 is present, M2 is not present, M3 is present. Okay. Then M4 is present, M5 is present, M6 is not present, 7 is also not present. Filling is over. Next we'll have to group these minterms and write the prime implicants for each group. Prime implicants in the sense row wise what is common and column wise what is common for each group. Okay. Octet is not possible because all 8 are not ones. Anywhere quad is also not possible. Then we'll have to go for pair. Always we should try for the bigger one first. Okay. Now pairing means what we can write. So these two are adjacent. We'll make them as pair. So let us call this as 1. And these two are adjacent. We'll make this as group 2. Now with two groups, all the four ones are covered. We have to stop. But somebody may write like this, group 3. Okay. So three groups are possible. This I have written with dotted. So third group also possible. Somebody may write. So three groups, three prime implicants we can write. Okay. So what is with respect to group 1? So these two ones in this row, hence it is X, and these two ones in two columns, here 0 0, here it is 0 1. So this 0 is common. With respect to Y, it is Y dash. This is the prime implicant with respect to first group. And the second group, these two ones, for that X0, X dash is common. Then for these two ones, there are two columns. In those two columns, these two ones are covered. Here 0 1 1 1. This one is common with respect to, that is Z. The first one is Y, second one is Z. So this is Z. Okay. So here 0 1 1 1, second one is Z, means Z we will take, X dash Z. Row wise for these two, X is 0 common, X dash, and for these two column wise 1 and 1 belonging to Z is common, hence X dash Z is written here. For first group, X Y dash. How many prime implicants we have found? 1 2. But somebody, if they write, what happens? For this, these two one, of course they make pair. So they fall in two rows. Row wise nothing is common. They fall in only one column. 0 1 is common. Z, this 0 belongs to Y. This 1 belongs to Z. So Y0 means it is Y dash, and here Z. Okay. So 0 1 is common for both one of third group. 0 1, that is for YZ. So this is Y dash Z, that we have written. Then how to write final simplified expression? We have to consider only essential prime implicants here first. Means here this first group, if you take, is there any 1 1 which is covered in this group only? There are two ones. This one is covered in this group also, in this group also, leave this. Then in group 1, here 1 1 is there, which is covered only in this group, hence X Y dash is essential prime implicant. We'll have to write in the final expression. Then second group, if you take here, X dash Z is the prime implicant. Observe ones in this group. There are two ones. Is there any single one which belongs to only to this group? So out of these two, this one belongs to this group 2 and this group 3. Leave this. Then another one is there which belongs to only this group. Hence X dash Z is essential prime implicant. It will be essentially in the final expression. Next, whether we have to write third one, yes or no. Third group, if you consider, in that there are two ones. One belongs to this group and other group also. Next, another one is there that belongs to this group and another groups also. There is no single one which belongs to only this. So in group 3, what happens? Two members are there. Once they belong to this and other groups also, means both are covered in other groups. Hence 3 is called as redundant group. It should not be included in the final expression. So the final expression is Fy is equal to xy dash plus x dash z. No need of drawing this group. Only these two groups are to be drawn. Why it is wrong if you draw this? Because in this group two ones will come which are covered in other groups also. Then no need of considering this group. That is called as redundant group. And what prime implicant we take here? That is redundant prime implicant. And it is not essential also. So totally there are number of prime implicants is 3. Essential prime implicants is 1 and 2. How many number of redundant prime implicant? 1. So like this in GATE questions, objective type questions can be asked. Giving the function, the number of essential prime implicants is 2. The number of prime implicants is 3. The number of redundant prime implicants is 1. Then what is the significance of redundant prime implicant? Since a member of that group are covered in other group also, it is redundant. It's of no use. It cannot be written in final expression. Hence simplified expression is Fi equal to xy dash or x dash z. Okay, that was example 5. So next one more example we shall consider. That is the last example, example 6. Here simplify F6 equal to sigma m of 1, 3, 4, 5, 6. So the biggest number is 6 here, mean term 6. So 1, 1, 0 it is in binary. To express this 3 bits are required. Hence this given expression is also 3 variable expression. Hence we have to draw 2 raised to 3 8 squares. So when this is to be simplified using K-map, we'll have to draw 8 squares K-map. So K-map of 8 squares is drawn. So 3 variables, x is written here, yz is written here. X may be 0 or 1, yz may be 0, 0, 0, 1, 1, 1, 1, 0. So drawing K-map is over. Now we have to fill the minterms. M0 is not present, M1 is present, 2 is not present, 3 is present, 4 is present, 5 is present, 6 is present, 7 is not present. Filling K-map is over. Next we have to group. So can we make octet here? All 8 are not ones. Can we make a group of quad? These we cannot make, 0 is here. This also we cannot make, 0 is here. This also 2 zeros are there. Then a rectangular anywhere we cannot make. So quad is also not possible. Next what we shall do? We shall try for pairing, right? So these two are adjacent ones. To cover this one, this only we have to draw. Let this be group 1. Now this one is in pair with this, because here if you make a fold, this falls on this. On this line you make a fold, this falls on this. Hence these two make another group. Let this group be second. So this one is remaining. Now this can be paired with this, or this can be paired with this. Okay. So if paired with this, let us write 3. Or it may be paired with this. Let us write this as 4. Any one will have to consider. Hence with respect to group 3 and 4, what we write, those prime implicants are called as selective prime implicants. In this group was redundant prime implicant because two ones of that group were covered in other groups. So it was a repeated one, redundant one, that was not used at all. Now out of these two here, any one has to be considered. Hence prime implicant 3 may be considered, or prime implicant with respect to group 4 can be considered. So the two prime implicants are called as selective prime implicants. What about prime implicant with respect to group 1? There are 2 ones. This one is covered in this, maybe in next one also. But this one, if you see, at least one is there which is covered only in this. That is why prime implicant 1 will be essential. Next, with respect to second group, this one is covered in this group, maybe in other also if selected. But this group members, out of these two in second group, this one is there which is covered only in this group. Hence prime implicant second also is essential prime implicant. But 3 and 4, out of that any one has to be considered, because this one if covered here, no need of taking this. That will be simply a repetition. It will become redundant. If you consider this, no need of considering this group, because that will become a redundant prime implicant. It will be a repeated one. That is why prime implicant 3, prime implicant 4 are selective prime implicant. Any one has to be considered. Okay. With respect to group 1, what we can write here? Prime implicant, these two. Here x is 0, x dash is common. These two ones fall in these columns. 0, 1 is there, 1, 1 is there. This 1 is common. This 1 corresponds to z. So it is x dash z. Then with respect to this is prime implicant, essential prime implicant, because this 1 is there which is covered only in this group. Next, second group, these two ones fall in this row. So x is 1 means x is common. Then these two ones are covered in this column, 0, 0, 1, 0. That 0 is common, which corresponds to z, hence x z dash it is. This is also essential prime implicant, because this one in that group is covered only in this group. If there is at least one which is covered only in that group, then prime implicant with respect to that group is called as essential prime implicant. Second one is also essential prime implicant. With respect to group 3, so this one, group 3, these two ones fall in this row, so x is common. These two ones in these two columns, 0, 0, 0, 1, 0, 0 is common with respect to y, so y dash, x y dash. Now fourth one, if you take this group, two ones, this row and this row, x is 0, x is 1, row wise nothing is common, leave it. These two ones fall in single column, 0, 1 is common, 0 corresponds to y, that is y dash, 1 corresponds to z, that is z, so y dash z, right? Hence the final solution is F6 equal to essential prime implicants will have to write x dash z plus x z dash. So with respect to this group and with respect to this group, these two ones are over. But to cover this, either this or this, 3 or 4. If you consider 3, x y dash, this is one solution, or F6 equal to essential as it is, we will write, instead of 3 now we shall write fourth one. So this is the solution for the problem number 6. So problem number 6 has two possible solutions, right? So where x dash z essential prime implicant with respect to group 1, we write compulsorily x z dash, one more essential we have to write, then plus out of two possible selective x y dash with respect to this group, because this one is covered in this, then no need of covering once again in that. So x y dash is a selective prime implicant. We may write the selective prime implicant 3 or 4. So 3 is written here, 4 is written here. So this is the final solution of the problem example 6. So I hope you understood. So what was the topic? The topic was the discussion on prime implicants, essential prime implicants. With respect to K-map, which is used for solving 3 variables Boolean function, considered here. K-map can be used for simplification of 2 variable Boolean functions, 3 variable Boolean functions, or 4 variable Boolean functions also. As we go on increasing the number of variables, it becomes tedious to identify the groups. Hence till 4 variables it is okay, right? I have covered in my previous videos K-map for simplifying 2 variable Boolean functions, and in one of the previous video K-map for simplifying 3-variable Boolean function also. In this I have explained what is prime implicant, how to find prime implicants, out of found prime implicants what are the essential prime implicants, what is redundant prime implicant, and what are selective prime implicants, and how to write the final simplified Boolean expression. I hope you understood. Thank you.